Hi everyone. Programming for Lovers is all about algorithms. An algorithm is a sequence of steps to solve a problem, but we can also think of an algorithm as a process that takes a collection of inputs and somehow converts these inputs into a collection of outputs. When we program, we use a function to represent an algorithm. You might like to think of a function as a building block that we're going to use to solve our computational problems. In this installment of Programming for Lovers, we will learn the basics of function syntax in Go. As always, if you enjoy what you see, please like, subscribe, and join our course at programmingforlovers.com. Let's code. The first thing that we want to do is create a folder that's going to store our code for this lesson. So let's go into our src folder, our source code folder within the Go directory, and create a new folder called functions. And then, as we have done before, we're going to create a new file in that directory and name that file main.go. This is going to be a runnable file, so we're going to have a package main at the top of our file. We're going to have an import statement where we're going to import FMT. And I just like having an initial print statement to the console, something like functions. Okay. So this lesson is going to be all about functions. And let's start with writing our first function. So in Go, we need to declare variables. And in the same way that we declare variables, we're going to also need to declare functions. So when we declared a variable, we had var, and then we had the name of the variable, and then we had the type of the variable, at least when we first started working with variables. And when we want to declare a function, we're going to have the keyword func, followed by the name of the function. And the first function that I want to write is going to be called SumTwoInts. And then we're going to have parentheses. And within those parentheses, we need to specify what is it that the input to the function is going to be. So I'm going to have this SumTwoInts function, and I'm going to have an a as an integer and b as an integer. So I specify the variable names followed by their types that I want to input as parameters into my function. And then I need to also specify the return type. So if anything is going to be returned by the function, I need to specify that type, and I'm going to specify that as an integer. So you could probably guess what this function is going to do based off of its name, which is good practice. We want function names that are descriptive. But another piece of good practice is to put a comment before all of our functions, specifying what it is that they take as inputs, what it is that they return as outputs, and what they do. So in this case, I'll say SumTwoInts takes as input 2 integers and returns their sum. Okay. Now we know how to sum 2 integers in Go. We can just simply say a plus b. We wouldn't need a function like this, but it's just going to be a simple function to illustrate the syntax of functions in Go. So in other words, if I'm given 2 integers, all I need to do is return a plus b. That's going to take the value of a, the value of b, sum them together, and return that sum. So this first line of the function, before I continue, I want to make a note. As I said, having a comment with the name of the function starting off the comment is good coding practice, and it will signal to the editor behind the scenes that a lot of times when you call this function later, you'll be able to see the comment that you wrote pop up. I also wanted to note that this first line of the function, this sort of declaration of the function, is called the function signature. So that's just a good term to know. And the signature in general is going to have the input parameters to the function, so the variables that we're inputting to the function, where you have the name followed by their type. And then, as I said, you have the output type of anything that we're going to return. This is a function that takes 2 input parameters and has 1 output. It's also conceivable that you would have a function that has more than 1 output. So I'm going to write a function called double and duplicate that takes as input a float 64. It's going to return 2 copies of that input variable. Okay, so this is another relatively short function and perhaps not the most useful function in practice, but a function that can help us start to understand and get comfortable with the syntax of functions in Go. So our function double and duplicate, I'm going to hit tab because it's already suggested it for me because I started my comment off with double and duplicate. And it's going to take, let's call our input variable x, and it needs to be a float 64. And here we're going to return 2 copies of the value of x. So I'm going to specify in parentheses that we have 2 float 64s that we're going to return. And then I'm going to have brackets to indicate the start and the end of the function. So in this case, we want to double those and return both of them. So I'm going to have another one-line function. Here I'm going to return 2.0 times x, and the second copy of it is going to be 2.0 times x as well. So that's our second function. In the same way that functions can take multiple inputs or return multiple outputs, they also don't necessarily have to take inputs at all. So for example, we could have a function called pi that takes no inputs and returns the value of pi, the mathematical constant. Okay, so this function, for example, let's call it pi, doesn't need any inputs, but it will need to return something. It needs to return a float 64. And this is maybe not the best practice in that it's returning a variable, pi is a constant, but in this case we could return our value of pi that we all know is equal to 3.14. All right. One more thing I want to say is we actually don't need to take any inputs or return any outputs at all. We could imagine a function called print hi that simply prints a message hi to the console. Okay, so our function would be called print hi. We still need the parentheses, but we're not putting anything in them, just like with pi. It's not going to return anything. And instead what we're going to do is print hi to the console. And that's all that that function does, but it's still a valid function even though it doesn't have inputs and doesn't have outputs. Typically, we're thinking about functions as these machines that process inputs and then return outputs, but they don't have to be. All right. In fact, you've already seen a function that doesn't have any inputs, doesn't take any outputs. You've already started to become comfortable with such a function, and that function is func main. So we think of main as a function also. When you compile a file, say you run go build, and you have package main at the top of your file, Go knows to look for func main. And so it will produce a compiler error if for some reason it doesn't see it. So these two things are tied together. When you have package main, Go is always looking for func main. So those two things have to go hand in hand. All right. So speaking of func main, let's come back to func main and let's use the functions that we've written. So these functions can be reused whenever we like, depending on which inputs that we want to give them. And using a function in that way, so outside of the function saying I have given values for a and b and I want to plug those into the function, that action is called calling the function. So let's call SumTwoInts in func main. And I want to illustrate an issue here, which is let's set x is equal to negative 2.3. And we should know that x has type float. So I'm going to set another variable n equal to SumTwoInts of x and x. It's fine to give it 2 copies of those inputs. And then we're going to print to the console the value of n. Let's see what happens. I'm going to save my file. In the terminal, because I added the Go folder on the left, the terminal has already navigated into my home directory and then Go. So I need to cd into src, and I also need to navigate into functions. Once I get there, you can see that I've made it. So let's try and compile this. And that's what we would imagine would happen. So Here, actually, it's not what we would imagine would happen. I did imagine we'd have a compiler error. Let's compile again. So we get this compiler error that says, on line 11, that's how we read that, and then character 18 on that line, we're not allowed to use x, which is a variable of type float64, as an integer value in the argument to the function. So in the argument to SumTwoInts. So SumTwoInts takes two integers as input, and in some languages you might be able to get away with this. You might have a sum function that's simply returning the sum. Go is very strict, and in time I think you will learn to appreciate this strictness with respect to types. If I declare a variable having type float, that variable can only be used as a float. It's not allowed in other contexts as that variable to be plugged into a function, for example, that takes two integers as inputs. So we need to be careful about this, and we were not even able to run this code. So this was a compiler error where Go is making sure that every time you call a function, that the inputs specified to that function in the function signature match what's given to the function. And that's a good thing. That's a good thing because it's going to make sure that we know what we're doing, that we're not applying functions in the wrong context. So as a result, let's instead change this to a valid integer. So we know when we declare x colon equal to 3, something like that, then x will have type int. So we're going to have two copies of x that get passed in. Let's save. And now we're going to compile. Now my code will compile, and I'm going to run this code by running the executable file functions that got created. And we see that the sum indeed of 3 plus 3 is 6. So our function does appear to be working, which is good. Let me give you one more function here since we're talking about an introduction of functions. Let's have a function called AddOne. It's going to take an integer k as input, and it's going to return the value of k plus 1. Okay. So func, the name of the function is AddOne. It's going to take k as an integer. It's going to add 1 to k, so it's going to need to return an integer type. And so within this function, I'm going to say, let's set k equal to the updated value of k plus 1. Remember, when we see expressions like this, we think about the expression on the right of this equation as being a value. So what is the current value stored in k? Add 1 to that. And whatever that value is, update the value of the variable k to be that value. So after I do that, I want to return that value. So I'm going to return k. And now let's go into func main and call the AddOne function. So I can set m is equal to, say, 17. And let's print what happens when I call AddOne of m. Okay. So we can run this. You might imagine what's going to happen, which is 17 gets plugged into our function, 1 gets added to it, and that's what gets returned. So we should not be surprised if the last thing that we see printed when I compile and run is 18. That's expected behavior. So you might wonder, why am I focusing on this function? Let's see what happens, though, if at the end of my function, I also want to print, at the end of func main, I also want to print m. And you might pause for a minute and think, like, what's going to get printed here? When we look into the function, we pass this variable into the function. You might think, well, that variable gets updated by having a 1 added to it, and that's what gets returned. So it might seem at first glance like what should get printed is going to be on this line. What should get printed should be 18. 1 got added to m. Let's see what actually happens. So when we compile our code and run, we're going to see the 18 got printed corresponding to the previous line. But on this line, we see 17 get printed. So then the question is, what's going on? When we call AddOne, a copy of this variable m that we declared is getting created. So when you call this function, this m is still somewhat preserved behind the scenes. And when we create this function, we call this function, a copy of that variable m gets created here, and that's what we're calling k. That copy of the variable essentially lives within the function. So k has the value of m of 17 at this point in time. We update k to be equal to k plus 1, so now k has value 18, and that value of k gets returned. So here, that value of 18 got returned, and that's what got printed. But k, meanwhile, is no longer necessary. So k only lives, it only has scope within the variable, within those brackets of the function. So as a result, m never actually changed. The copy only got changed, but m itself still remained equal to 17. Even if you rename these parameters, the parameter here, to m, and this might look strange, but it's the type of thing that you'll often see. I have a variable here, and that variable just happens to have the same name as the variable that's the parameter of a function. Even if we do this, you might think, well, this is going to tell Go that we don't want to create a copy. No, Go will still create a copy. So the m that gets created when this function gets called is a different m to the one that you declared separately out here in func main. The bigger picture principle that I'm trying to illustrate with this is that Go uses what's called pass by value for many variable types, including the variables that we have started to work with. So strings, integers, float 64s, symbols, these types of variable types. Go uses pass by value. That means that when you call a function, a copy of whatever variable you're working with here gets created, and that copy of the variable is what is passed into the function. So any changes that happen to those variable copies within the function don't necessarily affect the variables outside of the function that got passed into the function when the function was called. There are ways to use a different paradigm called pass by reference, so that if I passed m into the function, then it actually would be updating this m that lives outside of the function, so they would be tied together. Much later in the course, we're going to see how to do that and why you would do it. But for now, for the variable types that we've started working with, I want you to think about everything as being passed by value, so copies of variables getting created. Two more notes that I would make before we finish up this lesson. One is that the ordering of the functions that we have in a folder, or in a file, I should say, does not matter. So here I have func main at the top. You might like func main at the top. If you have runnable code, that's probably good practice. But I don't need func main to live at the top. I could put it all the way at the bottom or somewhere in the middle. Similarly, I could have functions that call each other as subroutines, and we'll start working with that soon. The order of the functions within the file also does not matter, so I'll prove it to you by saving this file, compiling, and running, and you'll see we get the same output. So that's a nice feature. You don't have to worry about the order of your files in a particular, order of your functions in a particular file. The other thing that I would point out, observation 2, is that as we're going to start working with more and more complex functions, these functions are going to take potentially more input parameters. And a lot of the times you'll have consecutive parameters as inputs to a function that have the same type. So Go has a nice little shorthand for working with situations like that. And one of the situations that we have here is in SumTwoInts. So if a and b are both integers, I don't need the first declaration. I'm just going to have a comma b, and then the int there indicates that anything before this, these previous two parameters, both have integer type. And I could have as many as I like, as long as they're all consecutively integers. So that's something that we will use often as shorthand for the rest of the course. But for now, I think that's a good introduction to functions, and we're now ready to start building more and more complicated functions to do cooler and cooler things, as you will see. That's it for now. Thank you for joining me, and until next time, happy coding.